Now we're going to talk about the file system. Yeah, I'm going to give you actually two definitions for the file system, so just bear with me. In Linux, everything is a file, and I mean every single thing is a file. There's a reason for that. If you have a text file, or not a text file, but a actual file that your kernel can touch and access, you can do stuff with it. In Linux, you can redirect output from one thing and send it as input to another thing. So I can actually view a text file, and instead of having it appear on the screen, I can send it to the sound card, and the sound card will make crazy noises because every single character that it reads is going to interpret it as a sound. It's actually a pretty cool project for you guys to do. It's pretty fun, but we'll do that some other time. So again, everything is a file. Memory is a file. Your video is a file. The audio is a file. Even the power is a file. Everything is a file. It has a structure. It's hierarchical. I can't say that, but you guys understand what I'm trying to say. Everything starts at the root, which is /, and from there it's kind of like a tree, but going down. There's a standard, the file system hierarchy standard. One cool thing about Unix is that you can make remote file systems look as if they were local. You will never know that they're somewhere else. It could be miles away or right next to you, because everything shows up as a directory. It's either a file or a directory, and directory is a file. So whether you mount NFS drive, or on Windows they use the SMB protocol, you can mount something as NetBIOS. You can just mount it into a folder, and you have access to it, just as if you were browsing to a different folder. There are no drive letters, so we don't have A drive, C drive, D drive, none of that. It's just plain directories. Now, if you look at the file system a little bit deeper down, yes, there's something that defines what the first hard drive is, the first partition, second, third, so on and so forth. Also, if there's a CD or DVD, whichever the case, or a USB thumb drive, there are designations for those, but it's just a folder that you go into, and it's depicted by just a file. We're going to take a look at that here in a little bit. All right, so the file system, like I said, there's two definitions for it. It also refers to the formatting of the device, of a hard drive. So basically, when you buy a new, let's say, thumb drive, and you plug it into a Windows box, it'll say, hey, I cannot recognize this drive. You want to format it now? And you click yes, and depending on what it is, in this case a thumb drive, it'll format it as FAT. You can also format it as NTFS, and that gives you more security options, gives you excuse me, permissions on over the file system. So every time you put in a file, you have permissions over it. You do the same thing in Linux. When you installed it, something that you didn't see on the background when you chose, I want to use the whole drive, is Linux doing a partition scheme, which is basically allocating space for the files, and there's a swap partition, we'll talk about that here in a second, and formatting it into the standard, it's called ext3 or ext4. It's the same thing in Windows. When you install fresh install of Windows, you got a brand new hard drive, you install it, it says, do you want to format it now? And you say yes, it'll automatically format it into NTFS. All right, so the file system, provides access to local files or over the network, and it's responsible for organizing data in an efficient manner. What that means is that the file system itself, so much like NTFS is responsible for where I'm going to put the data in what part of the hard drive, ext3 or ext4 is responsible for making sure that you have access to your data. And also try to keep it organized. That way you don't have a file at the beginning of the disk, another file at the end of the disk, so on and so forth. That doesn't happen as much in Unix as it does in Windows. Also, something very, very important is that in Unix and Linux, case matters. So I have 3 examples there. Root, which is /home/Joe, is not the same as /home/J, Joe, which is not the same as all capital Joe. And so 3 completely separate folders. In Windows, that wouldn't be the case. That would be the same one. For those of you who have a Mac at home, Mac kind of does the same thing, but it cheats a little. They have a kernel driver that tries to hide the case sensitivity. So the first one and the last one will be the same essentially, unless you start dorking around the command line. That's when you can see pretty much everything. Spaces. So you can do spaces in Linux. The file system will support it. You have to escape. It's called escaping when you put a backslash over a special character. A space in this case will be a special character. So it's going to be hard to get out of this. Oops. Let's see if I can. So, sorry, bear with me. Not my laptop. So, if you can see here, you can see that, right? There's a space there. I have to put that backslash for the operating system, or actually the shell, which will be the interpreter in this case, for it to recognize it. If not, it's not going to know what to do with it. It's going to give you an error.
So Windows and Linux handle some things like spaces or slashes or character case differently.
Correct.
And that can cause problems when you're trying to connect to something over the network using a path.
Correct. So there's I don't know if somebody has experienced this before, but sometimes when you go to a website and you start typing a URL, www.something.com, that's all lowercase, because the DNS, which is resolving the names, is taking care of the case. It doesn't care about case. It'll give you the correct IP. But once you go beyond that, sometimes you got to put a couple of characters uppercase, then lowercase, so on and so forth. They're probably using some type of Linux-based or Unix-based software, like Apache or Nginx or something like that, that it actually cares about case. If it's a Windows one, sometimes it doesn't care. I've seen it sometimes that it actually does care. It all depends. But for the most part, if you run into that problem, it's because they're using a operating system that actually cares about case. Everybody with me so far? Good? All right. Okay, so the file system hierarchy standard. It looks like a lot of stuff in there, right? Like in 1970, space was limited. RAM or memory was very limited too. Also, people didn't want to type a lot. These were all computer scientists, so they knew exactly what they were talking about. So they came up with this tree, if you will, and where to put the different files in a Unix-based operating system or Linux. You have everything starting from root or the /. You got bin, which is binaries. Can you guys see that very well? I don't know if you don't want to bore you reading every single thing on the slide, but if you can't see it, so bin is for binaries. Is user essential user command binaries. The boot static files of the bootloader, that's pretty much the configuration file and the actual boot image. There's a boot image that loads into memory that gives you access to certain parts of the system before the operating system actually loads. So all that stuff is in there. /dev contains all your device files, and like I said earlier, everything in Unix and Linux is a file, even the devices. So if you go /dev/smd1, it'll be your first sound card, or LPR or LPD1, it'll be a printer file. Everything is a file. /etc, it's etc. It's everything else. Mainly, it's all your configuration files. They're going to be in that folder. So when you guys are setting up different applications, you're going to spend a little bit of time in that folder. /home is the user's home directories. You can see the breakout /home/student/dir. /lib is libraries, essential shared libraries, and kernel modules. So this is basically your drivers folder in Windows. /media, it's mounting point for removable media. So basically every time you put in a CD-ROM, DVD, or a thumb drive, for the most part, most Linux operating system will mount it in a folder under /media. So you have /media/USB, or it could be /media/ the name of the thumb drive, /media/CD-ROM. It depends. /mount or /MNT. It's a mount point for temporary mounted file systems. So if you're working on something, let's say you have two drives on the same system, one of them's not mounted, but you need to do something real quick on it, you can always use that mounting point and drill down from there. /op or optional. It's an add-in application software packages. SBIN, system binaries. So that's where you find a lot of the administration type applications like ifconfig, passwd, which is to change your password, things like that. SRV or service, data for services provided by the system. /temp, temporary files. /user, it's for multi-user utilities and applications. So Linux is, I said this earlier, Linux is multi-user. You can have multiple people logged in at the same time, and the system will be useful. Not like Windows that you can have only one person at a time, unless you install other software. /var, variable files. This is where you're actually going to find a lot of the good information when you're trying to either troubleshoot or you're trying to find potential threat. Your log files are located under var. Var log is the actual directory. And /root is the home directory for the root user. And /proc or processes, it's a virtual file system that documents, it says here, documenting kernel and processes status as text file. So /proc is not really something that you make. The kernel actually takes care of creating that every single time you boot the system. What that does is gives you direct access to memory, video, processes, and all the things that are associated with those things. So if you feel like you want to play around, you can go to actually /proc as root and to type rm, which is remove. Tag F is to force, so it won't say, hey, are you sure you want to do this? And you put rm tag rf. The R is for recursive, and put /proc. you're going to delete everything you have loaded in memory. You're not going to delete the files that you have on the hard drive on the system, just your memory. So eventually you're going to see your screen go and disappear. It's going to eat itself, basically. It's actually pretty funny to watch. The cool thing is that if you just do it to /process, it's only memory. The second you reboot, you're back to normal. If you do it to the root directory, the same thing's going to happen, but you just host your system. So you don't want to do it to the root directory. And if you're doing that as root, root is, you know, the all. No, I don't want to say that. Blasphemous. Root is all in Unix. So when root says I want to do this, it happens. That there's nobody to question it. So if root says I want to delete you, you will get deleted. All right, the shell. So it's your command line interpreter. So basically in Windows is when you type CMD and hit enter, you get a little window with the actual shell. The actual shell is command.com in Windows. It's not when you type CMD. When you open up CMD in Windows, you get command.com. That's the old DOS interpreter. In Linux, we have different shells. We got shell or SH. We have bash, which is born again shell. And different instances. There's many, I can think of 8 different types of shells. Their own have their good things and bad things. The most popular one is bash, and we're going to see that here in a little bit. So the shell takes care of hiding and managing the technical details of the OS. What that means is when you're in the command line, you type, I don't know, let's say Firefox and hit enter. Without you what's going on in the background, you have a GUI, you get the browser opening up in your window. What the shell's taking care of is, who are you? Do you have permissions to run this file? Can you access the file? Is the file executable? Is there enough memory for this to open up? That's all the things that are going on in the background that you don't see. You just type a command and you see the result. You see a nice GUI pop up. The shell also provides extra functionality and convenience. Basically, when you are typing on the command line, little things like tab complete, you can start typing the first letter of a command or a file, whatever the case is, and the shell will recognize what you're trying to find. So if you're typing the name of a text file, you type the first letter and you hit tab, it'll fill in the rest of the name. If there's 2 or more that kind of have the same first letter, it'll give you a choice. So you start typing and keep hitting tab, and it'll autocomplete it eventually. Another thing you could do is you could do arrow up or arrow down, and you can go back in your history, the different commands that you have ran. Difference between Windows and Linux. In Windows, when you open up the command prompt and you start typing, you can do arrow up and arrow down just for that session. So the second you close it, whatever you did is gone. So you open it back up, and there's no history. You can't do arrow up, arrow down until you actually start running commands. Linux, the bash or the shell, excuse me, everything that you type gets written into a text file. So you're always going to have that history. As long as you properly exit the shell session, it'll write it into the text file. So next time you come back and open up the shell, you can go arrow up or arrow down, and you'll have that history. Other things are like, yes, go for it.
Can we work with Linux without ever going to the command line?
Yes, you could do pretty much anything or most anything via GUI.
So these guys, as they're administering and trying to fix their image that they get for their competition, almost everything they need to do can be done through a GUI tool also, right?
I would say most, but there's a lot of things that are just better via the command line, just because it's going to give you a better understanding, better picture, I guess.
So if somebody's afraid of it right now.
Oh no, you could do plenty just from the GUI. There's plenty of tools out there that'll help you out.
Real quick. So what we saw last year though with the Linux, headless Linux, no GUI came with it, so you have to install your own GUI if you want to do it. So
Okay.
that takes time, so it takes away from your competition time. You have to download, install the GUI and all that. So knowing the command line is very helpful.
So fear is appropriate.
Yeah.
Yes. So what I did, the images that I handed out, there's 3 images there. There's 2 Ubuntu ones. There's a desktop version that has a nice pretty GUI. Also gave you the server version. It has no GUI at all. So it's all command line. If you want to actually install the GUI, you will have to download it and wait for it, to install and so on and so forth. Then I also gave you another image is Fedora, the free version of Red Hat, basically. The reason I put that in there is because even though things are the same, you just do them a little bit different. And then in Unix and Linux, there's always more than one way to do the same thing. So something simple as installing an application in a Debian-based, which is Ubuntu, Debian-based operating system, you just type, D package. In Linux, you would type RPM, little things like that, which we're going to cover that here in a minute. Okay, where was I? Yeah, it's often accessed through a terminal emulator. So the applications that we open up when we click on terminal or whichever the case is, it's a terminal emulator which dates back to 1970 when we had the big mainframes and we had little machine here that actually connected to it. So now we have powerful machines. We just use a little application to emulate that same process. And like I said earlier, Bash is the most popular in Linux. So some common shell commands you're going to be using. If you're on the command line, you're going to use these a lot. But there's plenty more. I couldn't fit them all in a slide or bore you with multiple slides. So ls, list files, is the same as dir in Windows. rm removes a file, same as delete or del in Windows. cd, change directory, it's the same. Remember, Unix, there are no drive letters, so you don't have to type like C:, something, right? Find does just that. It finds whatever you're looking for. Man is manual. Get acquainted with that one, because there's an application that you want to know how it works. Just type man space the name of the application, hit enter, and most of the time it'll give you a step-by-step guide, or cat is concatenate, or it displays the contents of a file. So you type cat, name of the file, enter, it'll display it. Now, cat doesn't care that it's a text file or a binary file. You can cat a driver if you want to. It's going to say, hey, are you sure? But it'll display it on the screen, and you might hear some crazy weird noises going on with it too. So just pay attention to what you're trying to display on the screen. More does the same as cat, just one screen at a time. There's another command that I didn't put here. It's less. So you got more, now you got less. It does the same thing, but lets you go up and down. So if you want to go back to the beginning of the file or just scroll down, you can do so with less. Chmod changes the mode, or it changes the permissions. We're going to talk a lot about chmod and chown in the next presentation. Chown is change owner, just changes the ownership of the file. And grep stands for global regular expression print, which all you do is you give it a pattern and it'll go and find it. So if you want to find the word password, you would type grep pass and then a file, and it'll print out the line where the word, anything that matches pass is at. So if you type password, it'll match password. Okay. Processes and daemons. So basically the same thing. Process. I mean, a daemon is a process that's running. The biggest difference is that a process runs under direct control of the user. So basically, you launch an application, whether it's Firefox, Chrome, the terminal, you have direct control over that. So you can just click on something and you close it, and that's it. It only pertains to you. Whereas a daemon, think of it as a service in Windows. It's something that it's a process that's running in the background, and it's constantly listening for something to do. It's waiting for an action constantly. So a web server, and I have a bunch of examples here. X, which is the X Windows, the actual GUI that you're looking at. That's a daemon. HTTPD, which is the Apache web server. FTPD, SSH, anything with a D is a daemon. So SSH, FTP, telnet, named, NTP is time, named is DNS. Sendmail, that's also a daemon. It's actually the most widely used mail program in the internet, and it also has the most holes. So we're going to talk about security, that don't settle for the defaults. That's going to be on the next presentation. That's one of the things that I'm talking about, Sendmail. It's full of holes. If you're actually going to set up a server to use mail, MTA, don't use Sendmail. Try to find something else, something better. So the other examples, VI, Firefox, Chrome, the terminal, I already mentioned this. These are all processes that you have direct control over. So you can run processes from your local directory or the absolute path. So when I say that is, you can type /root/bin/ passwd. Or you can go into /root/bin and then just type passwd and it'll work. And you actually have to prepend it with a // but we'll talk about that later. You can put processes on the background. So when you run something on a terminal and you open the ampersand, it'll put on the background. That way you regain control of the terminal that you're using. And you can also bring it back to the foreground, so you have direct control over it. So I'm going to do a quick demo of what I was just talking about, foregrounding and backgrounding. So any questions so far? No? All right. So let's go.
I noticed in your version of the image that you gave us, there are a number of snapshots. Now, of course, we're going to be doing things as root, so we have power to destroy.
Correct.
If we mess something up, how do we recover? What's the best? Just shut it down and reboot? Always fix it? Or should we be doing new snapshots?
No, so when I created the images, I made a snapshot of a stable system, just in case you go beyond that point and you mess something up, or somebody messes something up, or it's something that you just don't like. You can always revert back to that image, that state that it was in. That at least you know it's going to be a good one. Whether you install something and you don't know how to uninstall it, or you delete the entire root system, you can always revert back to that image and you should be back in business. Okay, so all right, so if you can see here, I just typed in Firefox in the command line, and I didn't background it, right? When I ran it, it opened up. You can see Firefox here in the background, right? It's right here. If you can see my terminal, I have the the cursor is just blinking there. It's just waiting for something to happen. The reason is the command that I just ran is on the foreground, and it has taken over my terminal session. So anything that I do in this terminal is going to directly affect the current process that I'm running, in this case Firefox. So if I press Control C, you saw Firefox disappear, right? Because I just killed the application, I terminated the application. Now, I'm going to do the same thing and put it on the background so you can see Firefox running. You can see on my terminal Firefox backgrounded. Now it gives me the ID, which is the ones on the braces, the ID of the application that's backgrounded. You can have multiple applications on the background, and it'll just list them 1, 2, 3, 4, 5. It depends how many. The other number, the 1922 in this case, is the process ID. So it's just identifying what's associated with the current application running Firefox. So if I want to kill it, I can type kill and process ID 1922 and it'll die. So now earlier I did Control C and Firefox died, right? Control C, Control C, Control C, Control C. Firefox still there because it's in the background. It's not interfering with my terminal session now. I still have full control over the terminal session. Now, I can bring that to the foreground. Just typing FG. Now I have Firefox is in the foreground. And when I say foreground, I'm not talking about the GUI, what I see. I'm talking about the terminal session, the control that I have over the application. So now if I do Control C, it dies. So that's foregrounding and backgrounding. Just you keep the control over the terminal session when you background something. It's complaining because I killed it, but that's all right. All right. Any questions so far? No? All right. So yeah, we're back. So anybody got questions so far? I mean, that was a not so quick intro of Linux and some concepts.